All right, 4-57. Looking at the angles and the step, chamfer on the front, still think this back profile looks pretty good. We have symmetry. 80, see if I have some numbers to verify, 30 degrees. Yeah, we'll get the steps in as we go. All right, so going into metric part. Front plane, open the sketch. We know we're doing symmetry, so center line, vertical, infinite length. Pick up our bottom edge, up over 30 degrees to 15 degrees, flat across the top. Window pick, right to left, and we'll start putting the dimensions on. So 80, and we had a dimension of 10, an angle of 30, and an angle of 15. Make sure we stay in between the lines. Let's see, what does that give us for an overall? For the height then, we have 40, and then 65. Alright, so that gives me a good chunk of my geometry. We'll let that go ahead and extrude 40 millimeters. Alright, on the front plane then, we have that little setback. We'll go into the right plane then. So somewhere around here, over the little lip. Don't think I got the midpoint there, but we'll have to go back and check it. No, it's in blue, so that gives me the interior shape. We're 22 off of the base. So again, I can project that front edge in, and that'll give me enough to work from. 23. Let's see, what do we have for height? 10. And then the depth. Okay, I got the 10. Oh, 14 from the back edge. It doesn't look 23 and 40. It's about 17. Yeah, I don't think we're going to get there with 14, so yeah, went the other way. Alright, so what I'm looking at is 14 millimeters across this face, 10 millimeters on the ledge, so maybe 23, oh, that was 23 back from the angle. Alright, so I don't have the angle in yet, so I can't use that dimension. I have to go to the 10. Alright, that makes sense. Okay, so that gives us that little bit of a lip. Okay, and then extrude cut through all both. Sets the geometry, and then I guess the 30-degree angle carries over. We can try and do that with the chamfer tool, but I don't know that I'm going to have same control. So we'll save that one for just a second and go ahead and put in the rectangular. So select the midpoint, control select the origin, make sure that they're vertical. .30 millimeters wide, 15 millimeters tall, 5 millimeters off of the ledge. And they give us an 8 millimeters, but let's see how close it checks out. 7.68. Coming off that angle, yeah, I don't know that that isn't any kind of datum reference that I'd want to at rounds, but better off with the center line and off one of the prismatic shapes rather than the angle. All right, so question: do I go with the fillets? Well, it's probably going to break the symmetry. So going ahead and cutting it through is a better choice. So let's try the chamfer here. We have a length and an angle. So 10 and 22 would be 12. Well, 22 minus 10 would leave me 12. 30-degree angle. Let's flip the direction. And that comes up pretty close to that edge. And now if it didn't, if it doesn't have a mismatch there, then I'll call it good. Still have my reservations because I'm picking that upper edge, but as long as the other numbers work out. And then the fillet, 5 millimeters, and I could have done the filter and got all of my edges, but that gives me the geometry. Okay, so let's fly in 58. We've done this one before, so we'll stay with the up and over kind of that outside shape, do our pattern for the U shapes, and just kind of stay consistent there. So metric part. Let's go with the front plane. Okay, over and back. All right, some dimensions: 8 millimeter, height 35. All right, so since that didn't go to black, that tells me that I need to add a collinear or endpoint coincident. Let's see, the outside, well, still 8 millimeters, so my design intent is going to be that those three walls are going to stay equal. All right, dimension 21. Height is overall of 70. Let's see, overall width is 40. And that gets me to fine. So that looks a little bit closer, but not really, yeah. All right, so let's stay with our mid plane, or go back to the mid plane. 100 millimeters. We'll pick up the sketch, center line. All right, so I want 1, and I'm going to convert that to construction geometry. We can go to a tangent arc, pull it through. So that gives me the width of 1, full radius, and 12 millimeters. What else do we have? 14 for the depth. And then let's go to a pattern. All right, so linear sketch pattern, x-axis. We're going to have a total of 4. And dimension is 20 millimeters. All right, so pretty close. And what I want to do then is my points will be symmetric to shift everything over. All right, so what is missing on the other items? The 20 millimeter spacing. All right, so any particular point to the other should stay at 20 millimeters and extrude cut. So if I'd added the dimension, that probably would have been okay and got the same result. So in the linear sketch, when we add the dimension, it would have given me the 20 and maybe some other stuff that I didn't exactly want, but that will get it far enough along. Select midpoint and go to midpoint 60. So the takeaway from the linear sketch pattern is that it hardly ever goes fully defined. Occasionally it will. And most of the time you're going to add one or two relations or another dimension to get it to finish out. Alright, so extrude cut through all, and a couple of fillets to finish it out. And what did we have there? Fillets of 5. And a couple there. Let's see if we can tell front and back, none on the corners. Okay, looks pretty good. Okay, so circle, hex, and go with the contour and region. If this was any kind of clamp, where we're going to do like a clamshell or the half clamp, then we could, but 100 millimeters, almost 4 inches, that's pretty good size. All right, so we're just going to go ahead and split this front plane. If I wanted to look like the model or the example, would need to start on the right plane. So go ahead and get the hex in there. And across the flats, centered about the center line, so 35. All right, so just grabbing that inscribed circle. We need one of these to act as the vertical, and then to split it for our contour and region. Features, extrude, pick out our geometry. Let's go with midplane and 90 millimeters. Going into the right plane then. So this would be one of those cases where, because of the right plane and assigning the midpoint, I'd want to be really careful. 25 across the ends. If I did decide to edit the sketch plane, I could expect at least one error to come out of it through all both. All right, so let's give that a try. So right click on the sketch, edit the sketch plane. We go from the front plane over the right plane. I just got through sketching that rectangle. Continue and ignore. Yeah, about the same. So I don't know that I can edit that sketch plane from the right plane to the front plane and have the same result. Yeah, maybe not. All right, so let's go ahead and double click, change the sense. All right, so it's doable, but it probably wasn't that necessary. All right, so got lucky on that one. Would have been better off if I just left it. Going into the assembly, it's not going to matter. We're going to orient and position inside of the assembly based on whatever function it's got going on in our model. 460. Going to assume that the ½ inch goes through since there's no depth call out. 1 9/16 on the diameter. And then we'll cut the angle. So new, part inch, Front plane. Well, there again, if I want it to look like a model, I'm going to go ahead and pick the right plane. .56, 0.5, and we will extrude. Doesn't really matter mid-plane or extrusion, so back to 1, pick up the front plane. Our angle is 30 degrees, so we're looking along that edge, and kind of assuming that it's going to the midpoint. Alright, features, extrude cut, direction of the cut's okay, through all both, and save it. Okay, 461, we've seen 461 and 462, 463, 464, that one's new and that one's new. Alright, so we'll get through a couple of these and see how far we get. Alright, so 61. This is metric part. Has symmetry about the center line. We know from past experience, well, if we want it to look like the model, again, we're going to go to the right plane. And don't think it's critical, but diameter of 20 going through, assuming that is normal to the end face. The triangle intersects back here, so it either terminates at that face, which makes it a sink or EDM piece of geometry, and then being a triangle, it's already a challenge. Small, 12 millimeters, not quite half an inch. That would be, that'd still be a challenge, so we have to look at what that geometry does, if it's going to be valuable enough to run all the way through, or to have to sink it. So let's go with the center line, vertical, infinite length. And create our geometry. We haven't had much of a chance to use the continuous arc, but I'm going to come off, go back to the start point, and then pick up the line command. Up, step, over, and then up and over. All of that gets mirrored. Alright, so 60 between centers, or the bottom line. Overall height is, find it, 70. The radius is 12.5, and again we're assuming normal, not on the elliptical or on the cut back angle. Even though it shows those center lines tilting back, it's still, yeah, little interpretation thing going on there. 12 millimeters. We have a to the step. That's to the center. 10 millimeters on the height, and 6 millimeters on the instep. Okay, so that brings it to fully defined. Assuming again that the hole goes all the way through. That is 20 millimeters off of the 25 millimeters off of the base. And let's go with the triangle. Alright, so select the midpoint, control select the center line, make sure that those are coincident. We have 12 millimeters across the face and 15 millimeters on the overall height. And then off of the base, 45 millimeters. Okay, so if this was off at the angle, I think it would actually lower it down. So I don't know that we're gaining anything by putting it in relation to that 30 degrees back angle. All right, so let's go ahead with the extrusion. We'll go blind in condition, 90 millimeters. I would prefer it go the other way. And pick up the origin. Let's see. So our steps will be on the front plane. And again, I can either put in the continuous open profile or make two closed profiles. So if I go with the open profile, and we have the angle, 30 degrees. We are set back 32 degrees on the step. And depth-wise, nope, it's looking like 15 from here. Alright, features extrude cut. Flip side to cut, make sure we're cutting the outside. Alright, check box. Oh, not an open. Let's go through all both. And then there's where it intersects the geometry. Alright, so either that 15 millimeters from the step, but as far as the height, even if we went 15 millimeters down, we only have 20 millimeters there, so really need to look at that geometry. Height-wise, we have 5 millimeters, so 10 millimeters, 10 millimeters instead would clear. But, well, we'll have to make that decision, so 12 millimeters through. And make sure it's not grabbing tangency to something I don't want it tangent to. Let's just go with the horizontal first. And then from center, 12 millimeters off of the back. And that can go extrude cut through all. Alright, so interesting piece. There is fillets and rounds of 3 millimeters, but I only see 2 of them. So here, okay, call it 3 of them. 3 millimeters. And that will give me the geometry. Okay, so 62 has kind of this weird step. Again, the assumption is that this goes all the way through. If we're trying to generate that geometry, we're back at the wire EDM, trying to get that that kind of weird shape set up. We're off of 15 off of center line. Nope, 15 off of the base. So we need that max min condition for our arc to help us with that geometry. So metric part, stay with the right plane. Let's go with the 40 millimeters. We're going to share sketches and contours and regions. So 40. And don't know that I'm going to have one at center line. So let's just go ahead here. And we'll try not to pick up the quadrants so that I can build those in. Holding down the shift button, selecting the circle, going up to the line gives me a max or a min, whichever way it likes. So there's the 12 millimeter. We go up 8 millimeter from there. Okay, so it'll get a little easier to pick. The angle. So 40 back and 15 up. So let's go ahead and put that in as a center line just for reference. I don't know where that point will be. Let's put a point there for midpoint, considering I don't know where that point will be. Select, and then shift select the arc. Go to 15 millimeters. All right, so let's see, what was the, oh, and then 7 millimeters off of the outside. So does that add up? 12 and 8, 20. All right, so yeah, that would be on center line. And then 7 millimeters to the edge. All right, so don't want to make the assumption there, like I've done a bunch of times previously. 100 millimeters, selected contours. Let's go ahead and reverse the direction so that my sketch stays up front. And we'll show the sketch. And let's go ahead with the extrude. And pick up that geometry, offset it back 35 millimeters. Reverse the direction, reverse, and go through all. And so it terminates back. So let's just show the sketch. I don't think we'll have to pierce or anything. So that line at 15 millimeters will go through the front plane. All right, so probably could have grabbed the end point without too much problem. And then we're going 40 millimeters off of the back to our end point. Features, extrude cut, switch the direction, through all both, and there's our geometry. Hide the sketch, and go ahead and save. All right, so let's take a look at the next one. Same process pretty much as we have the undercuts and cuts, so contours and regions. Start on the right plane. Okay, so 40 millimeters and 32 millimeters. And then our steps will take place in splitting. So let's go ahead and extrude. And we want to extrude, oh, I guess I need the center. All right, so we'll extrude those first and I'll go back and add the center. Blind end condition for 100 millimeters. All right, so there's an internal diameter still for the notch. All right, so this little nub is 20 across, but that shouldn't affect, well, we'll see. It might. Based on the selection, it did. All right, so I need to edit the feature, and in the contour region, we'll go back and pick one more so that it makes it into the mix. All right, so the setback for our next piece, let's go with the extrude. Contour and region is the top. The from is offset 80 millimeters, which is probably coming towards me. I'm going to reverse it, flip the direction, and go through all. Okay, so that gives me the step. Last one will be to make the cut. And the cut is going to be that geometry to a depth of 8 millimeters. Open up the sketch, we'll go into the slot. What do we have? Let's go center point, no, straight slot. And we'll make it coincident. Nope, not midpoint, coincident to the origin. We have a width of 10 millimeters, length of 35, and from the edge to the center is 25 millimeters. All right, and then our depth is 3 millimeters. Okay, we'll go ahead and save it.